Okay, seventh grade. Today we're going to talk about properties. Most of this is just going to be memorization, but you do need to understand some concepts to know best how this works. So just take the notes, and there's really not going to be any real math involved. You're not going to have to do any problems. Just take the notes and answer some questions at the end. First, there are some terms that you're going to need to know. So if you need to pause this to copy it down, feel free. That's the beauty of a video. So the first thing is an addend. Addend is a number in an addition problem. The next thing is a sum. Sum is an answer to an addition problem. So if you have 2 plus 2, 2's are addends and 4 is the sum. Next is factor. Factor is a number in a multiplication problem. And product is an answer to a multiplication problem. So if you have 2 times 2, 2's are factors, and 4 is the product. Next is difference. Difference is an answer to a subtraction problem. So if you have like 3 minus 1, 3 minus 1 is 2, so 2 is the difference of 3 and 1. And last one is additive inverse. That's just a fancy word that simply means the opposite of that number. So if I give you, number 2, you can say that its additive inverse is negative 2, simply the opposite. The first property we're going to talk about is the commutative property of addition. So you have to memorize these names and how they work. Commutative property of addition simply means changing the order of the addends does not change the sum. So you have to think order, which order the addends are in. So here you have A plus B, letters are just numbers you don't know. So A plus B equals the same thing as B plus A. So if I flip them around in an addition problem, it doesn't matter, the answer will still be the same. So I have 6 plus 2 here as an example equals 2 plus 6, and you get 8 on both sides, so it doesn't matter if you flip them around or not, the answer is still 8. Same thing with the commutative property of multiplication. It works the same way. So changing the order of the factors does not change the product. Again, think order. So here I have A times B. Remember, if there is nothing between the letters, that means that it's simply multiplication. So I have A times B equals B times A. So 5 times 6 is 30. And if I flip them around, 6 times 5 is still 30. It doesn't matter if I go left to right or right to left. Order does not matter when it's multiplication. The next thing is associative property of addition. Think if you're associating with somebody, you're in the group with them. Changing the grouping of the addends does not change the sum. So think grouping. Here I have A plus B, the quantity, plus C, so I do A plus B first, then I do C, equals to the same thing as if I do B plus C first and then add A to it. To see it a little more clearly, let's look at our example. I have quantity 3 plus 2, which means I will do 3 plus 2 first and then add 4. That will be the same thing as if I do 2 plus 4 first and then add 3. So let's see how it works. 3 plus 2 is 5. 5 plus 4 is 9. Here, if I do 2 plus 4 first, I get 6, and then 3 plus 6 is still 9. So all I really did here is I had the set of these parentheses. Instead of having them around 3 plus 2, I moved them to 2 plus 2 plus 4. So it really doesn't matter which set you do first. So that's what the associative property of addition is all about. It works the same way with the associative property of multiplication. So again, changing the grouping of the factors does not change the product. Again, think if you associate with somebody, you're in the group with them. So if I do A times B first and then multiply by C, it's going to give me the same answer as if I do B times C first and then multiply by A. Again, if the letters are a little confusing for you, let's look at the one with numbers. Here I have 2 times 3 and then times 4, or I can do 3 times 4 and then times 2. It's not going to make a bit of a difference. All I did here is I took the set of parentheses around 2 times 3, and instead of having it around 2 times 3, I moved it to 3 times 4. So you can see that the parentheses are around 3 times 4 now. Is it going to make a difference? No. 2 times 3 is 6, times 4 is 24. Here I did 3 times 4 first, got 12. I did 12 times 2, and I still got 24 at the end. So all it is just moving the parentheses from around these two numbers to around these other two numbers. Now, identity property of addition. Identity, think identical. Identical, like the same number. They're going to be identical, like identical twins. So adding 0 to any number does not change the value of the number. In English, that means whatever number you have, here I called it A because I don't know what it is, A plus 0 is still going to be A at the end. If I had 6 pencils and you didn't give me any more, I would still have 6 pencils. So 5 plus 0 is still 5 because 5 plus 0 is 5, and 5 is 5, so this is true. So if you add 0 to any number, you will still end up with that same number. There is also an identity property of multiplication. It's a little bit different. Multiplying any number by 1 does not change the value of the number. Again, think identical. If I give you a number, what you have to multiply it by to get the same exact number? You have to multiply it by 1. So here I have some number multiplied by 1 is still going to be that same number. So for example, if I want 5 times something, and I still want to get 5 at the end, I need to multiply 5 times 1, and I will get the identical number at the end, which is 5. Next, inverse property of addition. So inverse, inverse is an opposite. It's a fancy word for opposite. So we talked about it in the terms. So additive inverse is just a fancy math word for an opposite. So if you have a positive number, the opposite of it is going to be that same number but negative. So the sum of any integer and its additive inverse, read the opposite, is 0. So here if I have a and I'm going to add the opposite of a to it, I'm going to end up with 0. So let's think. 5 plus negative 5 equals 0. See, they are opposites. So think about it this way. If I walked 5 blocks in one direction and then 5 blocks in the opposite direction, I would end up in the same place I started. So, or in the number line, if you go 5 to the right from 0 and then back 5, you're going to end up back at 0. We've done all this before in previous sections. So also, plus and minus together like this make what? They make a minus. So 5 minus 5 is 0. So 0 is 0. Kind of redundant, but that's how math people think. Next, zero property of multiplication. The zero property of multiplication says that the product of 0 and any number is 0. So I think all of you showed me that you already know that. So if you multiply anything, like if it's a trillion, gazillion, billion times 0, it will be 0. So 0 times any number, I call that a here, is going to be 0. It also doesn't matter if this number is positive or negative or fraction, decimal, whatever. 0 times that number is always going to be 0. So for example here, 0 times 5 is 0, and 0 equals 0, which makes it true, and we're happy. All right, last two. We have a distributive property of multiplication over addition. Multiplying a sum by a number is the same as multiplying each addend by that number and adding the products. A lot of fancy words. Let's see how it actually works and it will make sense. So here I have some number that's multiplied by a sum of other two numbers. And what I'm saying is that doing this is the same as multiplying this first number A by B, and then multiplying that first number A by C, and adding these two together then. So let's see how it works with real numbers. So I have 2 times the sum of 3 and 4. So if I just did it the way it's written, I would multiply 2, 3 plus 4 is 7, so 2 times 7 is 14. Or I can do it this way. I can do 2 times 3, and then I can do 2 times 4. So I did 2 times 3, and then I'm going to do 2 times 4. So I'm multiplying the first number by each of the addends in my sum. So when I do that, 2 times 3 is 8, 2 times 3 is 6, 2 times 4 is 8, 6 plus 8 is 14, and I still get the same answer regardless which way I do it. So that's the distributive property of multiplication over addition. Next, I have distributive property of multiplication over subtraction. It works the same exact way, only instead of a sum, you have a difference, which is an answer to a subtraction problem. So multiplying a difference by a number is the same as multiplying each number in the subtraction expression by that number and subtracting the products. Same exact thing as before. I'm going to multiply my first number, my factor out here, by each of the numbers in the parentheses. So it's going to be like a times b, which is right here, and then a times c, which is this right here. And then since this was difference, minus, I'm going to subtract these two. So here, for example, I have 2 times the quantity of 4 minus 3. If I did it just the way it says here, 4 minus 3 is 1, 2 times 1 is 2. Or I can multiply 2 times 4, which I did right here, and then 2 times 3, which I did right here. This is subtraction, so this is going to be subtraction also. 2 times 4 is 8, 2 times 3 is 6. I'm going to subtract them, I'm going to get 2 at the end. So this is called distributing. So I'm going to distribute this a to both of these numbers and get this. Okay, so pause this for a moment and name which property you think I'm using for these. And then we're going to come back and we're going to check them in a moment. Okay, so the first one, you got 0 times something equals 0. You get a 0 at the end, think 0, it's a 0 property of multiplication. The next one, I have negative 9 times 0, plus 0, and I still get negative 9 at the end. It's an identical number, and it's addition problem, so it's an identity property of addition. The next one, I have negative 5 times 1, and at the end I get negative 5, identical number, and I'm multiplying, so this is an identity property of multiplication. Next, right here, I had parentheses first around negative 4 and 3, but then I moved them to around 3 and 7. So since I just regrouped them and it's addition, this is associative property of addition. These used to associate together, now these two do. And then this one right here, I had negative 9 times negative 3 minus 7, this difference right here, but I changed it to negative 9 first times negative 3 minus negative 9 times negative 7. So I distributed this 9 to negative 3 and then to negative 7. So what this is going to be is distributive property of multiplication over subtraction. I'm going to work on these more tomorrow. Your job for right now is just to memorize as much of this as you can. All right, see you tomorrow.